So here is our first question. Let us see what does it say. The question says a bead of mass small m is threaded on a light rod that is pivoted to a point O on the vertical wall. This is a light rod. There is a hint for you. There is a light rod. This is a light rod. It has got no mass, and one of its end is pivoted to a wall. This rod can of course swing like this about point O. Initially the rod, and there is a bead, एक मोती जैसी चीज है. There is a bead of mass m on the rod and it can slide on the rod freely, right? There is no friction. Initially the rod is held in position with the distance of the bead at a distance x from point O. This is the bead. It is at a distance x from the pivot point O on the wall. The rod is released from this position and it rotates in vertical plane about O. Rod is released and it rotates in vertical plane about point O. Calculate the angle theta that the rod makes with the horizontal at time t after its release. You release the rod and the question is asking after t seconds what will be the angle made by the rod with the horizontal. The rod will come to some position like this. How is theta dependent on time? This particular question may look very odd to you because writing theta as a function of t is something which most of you have not done any time, isn't it? But actually the question is not that tough. Initial impression of the question is that it is really very tough, but it is not actually very tough if you focus on this keyword. It is a light rod. What does it mean? A light rod cannot apply any normal force on this bead. What am I saying? If this is a massless object, massless particle or very light particle, you cannot apply 100 Newton force on it. Do you understand that? If you apply any finite force on this, its acceleration will become infinity because F by m, m is 0, m is tending to 0. So acceleration will become infinite. Though that is not permissible. Even if suppose just for sake of argument, let me assume that I have a very small piece of paper in my hand and this is almost massless, it is very light, and by some means I am able to apply 100 Newton force on this. What is going to happen? This will have enormous amount of acceleration and very soon this piece of paper will be miles ahead of me. So how am I going to run after this and apply the same force? So practically we cannot apply any net force on a massless object. Similarly, we cannot apply an unbalanced torque on something which is massless, because if there is an unbalanced torque on some massless entity, it will produce infinite or enormous amount of angular acceleration. If this is our rod which is massless, and suppose this bead applies a normal reaction on the rod, just assume that this bead applies a normal reaction on the rod. So the hinge point, the hinge, यहाँ पे जो pin लगा है, जो भी कब्जा लगा है, the hinge will also apply some force on the end of the rod. Because the net force on the rod should be 0, it is massless. Therefore, the force applied by the bead will be equal to force applied by the hinge. Then only the net force can become 0. They should be equal and opposite in magnet. They should be equal and opposite, right? But such pair of force will form a couple, a torque. So if these two are forces acting on this rod, it will form a couple. It will produce a torque, and when the torque is not 0, because moment of inertia of the rod is 0, because inertia is 0, torque is not 0. It simply means its angular acceleration is going to be infinite. So this rod will have an infinite angular acceleration which is meaningless. Therefore, we can conclude that we cannot apply any net unbalanced force on a massless object. Similarly, there cannot be an unbalanced torque on something which has got no inertia. So this rod cannot experience a normal force due to this bead, and similarly the rod is not going to apply, and therefore the rod is not going to apply any normal force on the bead. If the rod is smooth, as I said that rod is smooth, if the rod is smooth and there is no normal force, is it necessary to say that rod is smooth? Is it necessary? No. No, it is not necessary. That's why it is not written in the question, I guess. If there is no normal reaction between the bead and the rod, there is no question of any friction. So that's why whosoever has written the question, he has not written that rod is frictionless. It's not necessary, because if there is no normal reaction, there is no friction. So when the rod, when you release this rod, the bead is experiencing a weight force, but there is no normal reaction, no friction on the bead. So what is going to happen? This particular bead will fall down with acceleration g. It will experience free fall. Don't you see that? The bead is going to experience free fall. Yes, believe it or not. The bead is going to experience free fall. Yes, dear friends, you have to believe this. The bead is going to move vertically down with acceleration g. So I have written that massless rod cannot apply a normal force on the bead, and therefore the bead experiences free fall in time t. It falls through a distance which is given by half gt square. If I release this object and it is under free fall, in time t it will fall through a distance that is given by half gt square. The situation will look somewhat like this. Bead has come down here. It has fallen through a distance y. What is this y? Half gt square. Why? Because this bead is falling down continuously with acceleration. Now everything is pretty simple mathematics, right? So this tan theta can be written as y upon x. In the question, this x is a given quantity and bead is falling vertically down with acceleration g. In time t, it has fallen through a distance y, which is given by half gt square. So I am writing tan theta as y upon x. Y upon x, y is gt square by 2 upon x.